Welcome everybody to the third masterclass in the series leading up to the New South Wales Smart Places Summit, June 22nd. I'd like to begin by acknowledging the traditional custodians of the land on which we meet today, despite the fact that each and every one of us is meeting virtually. We're each and every one of us on traditional lands of Aboriginal peoples, and in my case it's the Gadigal people of the Eora Nation, and I'd like to pay my respects to elders past, present and emerging. Welcome. As mentioned, we've still got a few more folks to join this session, but today we've got the third in the series of 10 masterclasses leading up to the New South Wales Smart Places Summit. Tonight is a really exciting one. It's about digital twin, and we've got some very, very experienced presenters who are going to talk to us tonight. So what I'd like to do before introducing the speakers is just ask you all to please stay on mute if you're not asking a question, or and there will be certainly times for questions. If you do have questions, if you can put them in the chat, that'll be curated by Mark Portlock, and we might ask some of you to come off mute to ask the question directly, depending on how many questions we've got. This evening's event will be recorded, and we'll let you know how to access the recording at the conclusion of the session. So without further ado, I'd like to very quickly introduce you to our speakers. We have great fortune this evening of really dealing with some very, very experienced folks. We have Adam Molan, Tim Mumford, Marie Truelove and Matt Henriksen, and I'll let them introduce themselves as they come up. But we are very, very fortunate to have these folks with us this evening. So without further ado, I will pass over.
So I think I'm first, Ian, so I'm just going to share my screen and then I'll introduce myself and kick off. So let me know if I'm not sharing the right thing, everybody. That would be much appreciated.
It looks good so far.
Thank you so much, Ian. So hi everyone, I'm Marie Truelove, and I'm going to be presenting with my colleagues Matt's today, but I've got the privilege of introducing the session today, and then I'll join later on this evening with Matt to provide sort of a demonstration of what I'm going to talk about first up. So I'm Marie Truelove. I'm a product manager in the engineering and design program at CSIRO's Data 61. I've been working on digital twins for the last 3 years, or data platforms for digital twins, I should say. And I'm really, this little presentation at the beginning of this session, it's about 5 minutes or so, is really just to present some high level definitions around some of the words you might have seen used to describe digital twins in Australia recently, and some of the concepts to characterise them, such as maturity models. So it's very high level. I'm going to skip through things really fast, but no fear if you miss anything. All the references are in the slides and they'll be shared with you later if you're interested. So I've been really loving talking, kicking off my presentations this year with some market research, just to sort of give an indication of this, the evolving and the predicted evolution and growth in digital twins. And I use this particular one, which I've seen quite recently, because even though there's many to pick from, because it actually called out urban scale digital twins, or precinct scale or place digital twins, where I think much of the research before that has been very focused on different scales. I like to start my digital twin conversations, perhaps not necessarily with a definition, but with the question, what does digital twin mean to you? One thing I've observed and I've learned since working in this field is that digital twin is an enormously opportunity for collaboration. And so asking these kind of questions helps you talk through what it means to you. And one thing that I find really, really interesting is that the consensus, regardless of application domain or where people are in their maturity or adoption of digital twin, we really do understand and come to consensus quite quickly that a digital twin is a digital representation of something in the physical world. Different words might be used, like you can see on this slide, from the definition from the Digital Twin Consortium. And most importantly, the twinning part, that it's connected or live or kept in correspondence with the real world. And as soon as you've got past that, the next thing that the conversation will go is you define this, the application domain. And for us, the easiest way to do that is to really narrow in on scale. And so I think if you're not aware, the founding scale of digital twin was certainly in the industrial manufacturing kind of scale. I've seen that even the NASA Apollo program was credited with with the term digital twin itself. And I like this figure because it really sort of brings that across. At the urban scale, the first pioneering work that had a significant influence here in Australia, from my observation, was Virtual Singapore, and also the Gemini Principles, which were published in December 2018 from the Centre for Digital Built Britain. Fast forward today, it's only 2 years later really, it's really gained significant traction at this kind of scale. In addition to things like this masterclass becoming a major topic for Smart Places Summit later this year, another example is the Open Geospatial Consortium, a very influential body for open geospatial standards, convened their first Urban Digital Twin Summit in January this year. And this is one of the opening slides from the keynote with definitions and application domains. In the Gemini Principles, the Centre for Digital Built Britain also defined a national digital twin, and I really just wanted to call out that it's not one twin to rule them all for the whole country or something like that, but the intention here was really an ecosystem of connected digital twins. And so we're starting to get into that. There's a lot of capabilities besides the twins themselves, but how do we share data between them is another sort of thing to be thinking about. And this concept really resonated with us here in Australia, and our work at Data 61 in sort of the data platform sort of space, as it speaks to the truth of our experience of a federated data sharing ecosystem, and pragmatically the approach required in a country with 3 levels of government of our size, perhaps in comparison to the early exemplars, which was the Virtual Singapore's. It also resonated with ANZLIC. If you don't know them, they're the Spatial Information Council, or the peak intergovernmental organisation. It really provided them then a highlight there that an ecosystem of digital twins, that vision needs to be underpinned by spatial and positioning information. Put simply, so all the data can be located in its real world context and relative to each other. So the characterisation of spatially enabled digital twins makes this really explicit. And so you might see, we'll talk later about the New South Wales spatial digital twin, and that's where that comes from. At the same time as we're building our vocabulary around how do we define digital twin, we're also characterising, there's also frameworks emerging to characterise the twins themselves. And some of these interesting ones at sort of at the precinct kind of scale or urban scale. Here's one from the Smart Cities Council of Australia and New Zealand. It presents 5 capabilities with a minimum requirement to be a digital twin. ANZLIC also published a maturity model, and its phases are defined as increasing evolution, complexity and connectivity and capability. And also I spoke about there's also the underlying capabilities that we're going to need for an ecosystem of digital twins. So there's maturity models for data sharing, with the goal state being federated data sharing. And the final one that I'm going to show, which was presented at the Urban Digital Twin Summit in January, that I thought was really interesting, is it just squarely focuses maturity on just the data itself, which is, fundamentally one of the challenges that we're facing as we mature towards a digital twin future. So it's not just taking our BAU 2D spatial data and transforming it to 3D and 4D, but also combining with data from other sectors that were traditionally siloed from each other. So we're talking building information models, IoT, and asset registers. So I think the key takeaways that I wanted to leave you with from this brief intro is that digital twin is definitely an opportunity to collaborate. And it starts with the question, what is digital twin to you? Perhaps rather than the one I've heard a lot is, what is a digital twin anyway? Urban scale, spatially enabled, precinct scale, digital twins are really in a period of rapid evolution and growth. I think we're only kind of at the beginning, even though it feels like we've been talking about it now for a little while. Federated data sharing from multiple sectors will be a fundamental enabler for the ecosystem of digital twins. That is the vision for the future. And the other thing I wanted to take away, perhaps for your organisations, is that in our experience, or from the way we've experienced the digital twin, is it really is a journey. And I'd encourage viewing maturity models as a guidance for evolving capability in that journey, perhaps rather than a barriers to ambition. So we're not there yet. We're not going to call it a digital twin. I'd really encourage people to have that vision of digital twin. I'm going to be back a little bit later on. If you have any questions, for now. I'm more than happy to pop them in the chat, and I'm sure Mark will let me know if there's something that we should answer. But other than that, I'm going to stop sharing my screen and pass back and introduce our next speaker, Tim, who's here. Fabulous, Tim. So I'll hand over you to introduce yourself. So thanks, everyone.
Thanks so much, Marie. And it's this is designed to be a masterclass, so hopefully, you know, a facilitated conversation is absolutely the end of the game. And thanks to you for giving us the 101. And I see all that stuff, and rockets me into how, in many respects, ambiguous the future is. But I'm sort of comforted. We don't have really a clear definition for cars, but we're happy to get into them every day, and we don't need a definition for cars. And so, bedding down a full definition for this stuff is something that I'm okay with us not having at the same time. Could I get a bit of flavour if you can see my screen? Probably one of the most used catchphrases for 2021, I hasten to add.
It's all good.
Beautiful. So this may seem like a bit of a fish out of water in terms of a sequence, but again, this is a masterclass, and I think it's fortuitous timing, Ian and crowd, insofar as I guess we're right at the synchronous spot where Infrastructure Australia is coming out with their legislative role on policy that the governments of Australia should adopt for the infrastructure sector. Infrastructure and construction sectors, public works, infrastructure, construction sectors, over the next 15 years. That opportunity rolls around every 5 years. And I'm proud to say that there is a major focus on digital innovation within Infrastructure Australia. We've got some really good expertise here that we are driving this conversation very hard. I would like to say, for the first time within, I guess, the infrastructure and construction sphere, of federal government, in a sort of broad and balanced perspective based on experience. So without further ado, this isn't just a hammer looking for a nail. I want to emphasise that we actually have a problem to solve here, and that problem to solve is productivity. It seems like a lot's going on here, but I want to impress that if you look at productivity, and we can debate what productivity as a measure is, but whether you talk to a construction manager or you talk to a financier, or if you talk to a macroeconomist, on pretty much all accounts, productivity in our sectors has been stagnating over the last 30 years. It's about 25 to 28 percentage points as compared to all other market sectors here in Australia. And that's just engineered construction, and that obviously has knock-on effects to residential, commercial, and just how affordable stuff is. And the top graph here is kind of a flavour of that. You can see inflation of the construction and infrastructure sectors globally as well as Australia on that curve, and then the average basket of goods over the same period of time. What this means in reality is that infrastructure is less and less affordable as time goes on. So we have a problem to solve. The good news is we're coming from a relatively low base, and I think there's some quick wins. There was recently a bit of a study on time spent on infrastructure projects, and if you look at the 40-hour weeks of the project management design houses on most infrastructure projects in general, to be honest, something like 35% of that time was spent looking for old information, rework, clash detection, and just a sneaky little calculation, even with conservative estimates on our forward estimate and pipeline, you're looking to save 10 to 50 billion just with conservative estimates on sharpening that up. It has massive knock-on effects, and we all know the story all too well about cost blowouts, etc., etc. I mentioned that it was a relatively easy story and problem to solve. It's hard, I hasten to add, but it's the good news is that we're coming off a relatively low base. Construction writ large is the second least innovative sector, bar none. There was a study done by ABS in 2015, which highlighted across a number of variables, wage growth, unionisation, a whole bunch of other things. Innovation was one of the statistically significant drivers of productivity in our sector, bar none. So there's massive opportunity. So what are we here to do about it? The first thing I think is actually to mature the conversation. You just heard me say that I don't think we need a definition. I don't think we do. I do think we need to mature the conversation, at least at a top tier of government level, around what does innovation mean? Because if you ask everyone, they've got a different perspective. Generally, it's around NBN, which is one part of it. So what I wanted to do is articulate that it's more than that. It's looking at digital and innovative approaches to create and operate infrastructure. And as Marie rightfully pointed out, that is spatial, that is IoT, that is BIM, that is digital engineering, whatever you want to call it. There's also that element around digital and innovative infrastructure and its own, it's on its own level. And that is talking about 5G and NBN and, robots and smart cities and everything in between. But I think the third and most important one, and there's been some movement across Australian governments, which is fantastic to see, is to start to value data and information as an infrastructure asset in its own right. And I think the departure of thinking on this is slowly starting to change, which fills me with great hope, is we value a public asset like a school like an asset, and it's got a value and it's on a balance sheet, but we don't have the same regard for licensing information. That is an absolute asset, and to be honest, if you're then broaching down the conversations about asset recycling, it's got value to everyone else. It's certainly got asset value or value just in general to the average Australian, particularly if it's a productive asset. What are the barriers? I'm sure all of you are very familiar with this. What I want to emphasise on this slide is all governments in their entirety, generally working in unison, have a role to play. They are the creator of public works infrastructure. They're the regulator of it. They're the benefactor. And so they have multiple roles to play, bar no other industry. So there is considerable opportunity and upside. And I just want to emphasise that it's not industry's problem to solve, particularly when we keep asking them for paper. So a bit of feedback. Some of you were consulted in this in our engagement over the planned development. None of this stuff will surprise you, but it was good to hear it. I wanted to sort of develop up a bit of a map and a bit of a flavour of what are the opportunities that are sitting right in front of us if we choose to grab them. And on the top is sort of the problems that we're seeking to solve. So like, what are those nails rather than just the sake of doing BIM or digital engineering or digital twins for the sake of doing them. And then what are the products, as it were, on the left side, and which ones can solve which problems. And what it's occurred to me over this period of time is it's not about the technology, it's not about the digital at all, it's just good information management. And if you think about the life of an asset, it's really just about how you structure the information, whether it's on paper or not, or in an Excel format or an object-based data set or an IFC model or whatever it is. It's just making sure that most people can use it and leverage it, and it's valuable, not just for yourselves, but well into the future. So it's just good IM, and it just happens to be made snazzy by digital, which is not the end of the world, and I think it sells a lot of things, which is not too bad here. So we're at the pointy end of the plan, which is our legislative role. I mentioned here at Infrastructure Australia, we are going pretty hard on the conversations about digital in infrastructure and the reform options. The federal government have to respond to this per the legislation, which is fantastic. So I guess I urge you to all sort of get behind this as much as you can. It's within the industry innovation productivity theme, which is one of the cross-cutting themes within the plan. There's talking about a lot of things here, but it's also talking, all the way from contract standardisation, all the way to roles and responsibilities and funding and financing. But one of the key sort of parts is that digital by default, if we're talking about the productivity picture. And that's what I want to talk about today is where are we heading? What does good look like? What do the reforms as they're currently written look like? No, I don't think anyone on this masterclass will disagree with me, but the key message really is to find the tools and practices and systems and processes and capability to unlock those productivity gains and efficiencies that I was talking about. That's the goal, to support the average taxpayer and to make sure that we can deliver more infrastructure for the same price to move our nation forward, but also to be more exportable as time goes on. the objective is to embrace those opportunities to create better infrastructure in its own right, not just stuff that we're not building monuments, we're building outcomes. And then moving over to that federated integration data sets, digital twins, and then drive some consistency. So rather than doing things 7 times, let's do it once and do it right, so we can drive some efficiencies through that and not waste or get to another rail gauge problem, which we've already found out, and I hasten to add, probably beginning to find out as we speak. So the recommendation is, in its entirety, as a summary level, is to increase the productivity as the outcome and the culture of innovation in the sector, and basically adopt a digital by default approach. So let's move away from paper. And the actions and actors in this, and there's obviously a lot more detail behind this, but we're using a theory of change model. We've done countless engagements. We've spoken with several other foreign governments about how what they think is the right way, I guess, given our circumstances. And what we've landed on is effectively a national office, effectively, for this stuff, digital by default. You could tie it back to a Centre for Digital Built Britain's sort of environment. There's equivalents in Denmark, America, Singapore, et cetera, but it is that sort of central oversight to drive this consistency. Yes, there are these sort of similar agencies within the Commonwealth. A pretty big gap analysis that we performed highlight that they weren't really playing this function, and this role is absolutely critical, particularly the voluminous money that is being spending post-COVID. And then that group is basically tasked with creating a national roadmap for this sort of stuff in concert with the jurisdictions. And then that should be embedded, BAU, into pretty much every project moving forward. And if there is Commonwealth funding, it should be tied back to those kind of outcomes. And then eventually working through a network, and then working through what we're calling the Intelligent Infrastructure Innovation Scheme. Don't be blindsided by the name, but the long and short of it is basically working with all the jurisdictions to develop up what good looks like for them in concert with one another to incentivise good behaviour. And the good news is, Ian, you're ahead of the curve in many respects. But you're probably nodding furiously that this would have been nice 5 years ago, which is what we're trying to drive today. And the goal is, many respects, teach to the top, and then keep pushing and leverage some of the good work that you've been doing, as well as other governments across Australia, but pull it in concert. And I hasten to add that, Victoria, Adam is doing some great work, as well as New South Wales and Queensland in this space, as well as Canberra is doing some good stuff as well. The next part is moving towards effectively creating those same offices or replicating that sort of environment within jurisdictions and getting behind that. As a man that's been part of that environment, it is very hard to break the silos of traditional government, and I think that cross-jurisdictional sort of group or entity or AO or however you want to establish it is the prerogative of the jurisdiction to start to integrate across those movements as those elements, as Marie just pointed out within that spectrum in one of her last slides. Again, there's still a role for project teams and industry, but to implement it. As Simon Vo likes to say, let's stop calling this digital engineering and let's start just calling it engineering. So I'll pause there. I'm sure you got some questions, but if they're sort of generic to the group, I sort of ask you to hold them over and we can debate them as a discussion as per the masterclass.
All right, I'll jump in now unless there's no questions. Feel free to take the mic, anyone, while I set up my screen.
Or you can always ask questions in the chat.
Cool. Ian, I'll get you to manage any questions. Obviously, I've gone a bit blind at the moment. Am I right to go?
Yeah, your slides are up. If you could just put them in presentation mode.
You can see that now. That's in Preso mode.
We can still see the basic slides, but if there are technical challenges, I just suggest we press on. There we go. That's good.
Okay, fantastic. All right, so look, there's a lot of familiar names in the audience, but for those who don't know me, I'm probably wearing 2 hats today. One is as ASCA president, so ASCA is the Australian Smart Communities Association, and the other is the Digital Twin Strategic Lead for DELP. DELP is the Department of Environment, Land, Water and Planning down in the Victorian government. So I have previously worked with, or actually didn't quite work with, Tim Mumford when he was down in Victoria, and obviously know the audience really well. So look, first of all, thanks for the opportunity to have a chat today about digital twins. And when I was given the opportunity to spend some time with everyone, I really sort of sat there and thought, okay, what's the best way to sort of structure this sort of presentation? And to me, I always am reminded by, you know, computers, the parts to a computer all existed in around sort of 1910, 1915, and it took, you know, 40 years to put them all together and create the computer. And I think digital twins are very similar in the sense that, you know, we have all the data, we have the analytical capabilities, we have the technology, and we've just got to all tie it together. And that's really by, you know, the collaboration and the data standards and requirements that you know, bring it all together. So you know, I'm going to spend a bit of time talking about that and a little bit of sort of scene setting for everyone. You know, in terms of where I come from, I have previously led a smart city program out at Wyndham City Council, which is the 8th largest council in the country. So it was a outer metro council. So I really got to sort of sit there and understand and work through strategic smart city visions and the tech side of things as well. And, you know, how do you operationalize this type of work? And, you know, then I took up this great opportunity with the state government to lead some of their digital twin work. And, you know, to me, the concepts are really, really similar. I don't think you can have a smart city without a digital twin, and, you know, a smart city obviously requires the digital twin, and digital twin is part of a smart city. I think where they sort of separate a little bit is we talk about micro mobility and stuff like that. Sort of sits more in the smart city space, not so much the digital twins. In terms of where I come from, it's a spatial geomatics background, so I do have a very strong experience in, you know, in data and standards and, you know, 3D modeling and all this sort of stuff. And, you know, it's a nearly, I shouldn't say it, but nearly a 20-year career now, so I'm sort of well experienced. And, you know, the Australian Smart Communities Association is a representative body predominantly of local government members, and that's where a lot of my focus has historically been and continues to be as part of that role. So you will get that sort of that sense in a lot of the discussions that I present today and how I sort of discuss digital twins, the angle that I take. You know, I don't really need to go over a few of these things too much because I think Marie did a really fantastic job at the start talking about where digital twins have come from. But it's really important when we talk about urban digital twins, and, you know, that number of 500 of them going to exist in the world within, you know, the next 4 or so years is really important to put in the context of where data standards and stuff are coming from. You know, and they generally, you know, sensor standards come from a manufacturing space. When we talk about urban digital twins, it's really about tying these things together. So there is still a little bit of work to do in terms of ensuring that collaboration and integration of different systems. So it's a really important piece. You know, when we talk about a digital twin, it's really, like Marie said, it comes down to what someone wants. It could be a 3D image mesh, for example, all the way out to something that really does require, you know, that live data that allows for, you know, automation of decisions and stuff like that. So there's all these different scales, and it really does come down to the problem and the use case that you're trying to solve. So I don't think there's any great need to sort of get too sort of picky around what a digital twin is. To me, it is very much just up to the user and how they see the replication of the real world. You know, and that obviously does include, you know, some really complex city functions that are live and continually changing. You know, as I mentioned, it's a key part of, you know, places. Actually, it's objects, places, communities, cities, state, nation. I mean, we've seen the smart digital twins for the globe that are being proposed now. So there's all different use cases, and depending on those use cases, the scale needs to change. Yeah, and a digital twin to me really has those 4 key functions, and that's around looking at the historical stuff, so understanding what's happened in the past, what's happening now, how can we predict things in terms of just the near future, and then really some of that sort of planning component, so, you know, planning a new bridge or some infrastructure piece, these types of things. So there's so many different capabilities in terms of a digital twin, and I think that's to me the really exciting part around it. So when we talk from particularly both a local government and a state government perspective, you know, there's a number of drivers that are really allowing us to sort of, you know, take these early steps into urban digital twins. And, you know, the first and foremost to me is really the size and cost of sensors. You know, they are falling drastically. You know, these bridges here, they've got sensors all over them, and you know, pergola, sorry, or whatever you want to call them. There's sensors all through them, and they're counting people using this type of feature. It's looking at the structure integrity and all this sort of stuff, and you can barely even see that sensor. So, these sensors are getting smaller and they're lasting longer, and it's really sort of coming to a space where we do have this sort of technology-driven society now that allows so much more in terms of maintenance to planning and all that sort of stuff. So, these are really critical outcomes. I think when we talk about the maturing of technology, and that goes from everything from the machine learning capabilities to the way that we visualize data, to the way that we join the data together, the different types of access available through maturity of the use of APIs, and all these types of things are really allowing us to drive to the creation of digital twins, and really quite mature digital twins. When we actually talk about why do we do this, why should we have a digital twin? To me, the key one and the biggest value opportunity, return on investment opportunity, is around removing data silos that exist. And this isn't just within government departments, it's across different government departments around different layers of government, but also, obviously with the private sector, engaging with the community and all these types of different groups. So to me, that's one of the big drivers, and that's certainly driving a lot of the work down in Victoria. To me, those digital twins allow us to really understand those multi-dimensional use cases. So when I was at Wyndham, and we had smart barbecues. Now the barbecues, we put a whole range of different sensors on them, and they were put on there not to solve essentially city problems. It was all around operational maintenance. So if a barbecue wasn't working, we could send someone out to repair it or clean it. But it actually gave us these really interesting insights around why was someone using a barbecue when it was like 6 degrees outside in the middle of winter, and it helps you understand the impacts of socioeconomic issues and all these different elements, and you start to plan, okay, maybe we need some better lighting in there, or if people are constantly using the barbecues, maybe you need some toilet facilities and all these types of things. And you can't get that if you're just looking at a single data set. And by having a digital twin concept or proposing a digital twin lens over the top, you can sort of dive into that piece of work. So it was really some fascinating findings that we have in what I call these multi-dimensional use cases, or discovery sessions in a way. And I think, look, it's really important to sort of call out, these grant programs. The Smart Places one is, just a brilliant program, but a lot of it did begin with the Smart Cities and Suburbs program. That really did set a fire under the local government sector to really start to embed these types of sensors and thinking around data. So, I think there was a lot of great learning there, and I certainly saw that across a number of our member groups in ASCA. So to me, the absolutely primary reason for digital twins is it really helps us to understand what I call unlocking the art of the possible. And we talk about a future where we can use different data sets and planning based data to understand how policies will actually impact our society. So if we sit there and say, okay, if we change a height limitation, what does that mean in terms of the number of apartments that can be put in there? What does that mean in terms of traffic? What does it mean in terms of access to public transport? These types of things. It allows us to take in so many different data sets that we never have been able to even conceive, and bring them all together and really understand what different types of impacts are going to have on our various city functions. And to me, it's about imagining this type of future that we can look at both the historical components all the way out to sort of planning the immediate, and then start to look at what's going to happen in the future. And that really becomes a fantastic way for us to collaborate, both around built environment proposals, but also around helping engaging with our communities, who at the end of the day are the key reasons why we do these types of digital twins. I think this is, I keep hearing that digital twins is about data, and clearly there's a data is a primary component of it. It's a building block, whether it's a 3D model is the building block, or the underpinning geospatial foundational elements. These are all key parts of digital twins, but when we actually think about a digital twin, it really comes down to the ability to think innovatively about what the data can solve and what we're looking to solve. But it's also about having the ability to piece together that sort of thought leadership, but also the ability to analyse that data. And to me, it's equally as much about an analytical problem as it is about a data problem. There are so many different data sets available that we've got to work out how to harmonize those data sets, join those data sets together so that they can work cohesively together, both in terms of time epochs or accuracy levels or capture regimes, these types of things. So it's about coordinating that component. And when I sort of think about digital twins, and particularly where Australia is more broadly, a lot of it is in that planning and visualization space. And you can see that here. This is a Fisherman's Bend digital twin that was done a couple of years ago down in Victoria. And that work is has been very focused on planning outcomes, so making sure that we build better communities, but it hasn't sort of stretched that so far into the operational capabilities. And I think that's the real next stage of maturity when we talk about, both the operations component, but connecting different digital twins. So you might have a digital twin of a building or a smart building, as we like to call them, and then integrating that with a city-based thing. So you have two different owners of a digital twins, or a digital twin for Melbourne Airport, and that links in with the digital twin for Victoria, which might have transport information, for example. So I think that's a really big case around how we can also look at the maturity. What I wanted to do now was really step through some really interesting data sets that are actually housed almost in discrete locations, and what needs to happen, I suppose, or wouldn't be great if these things were put into digital twins, and really that comes down to access protocols, open data elements, even authentication systems around managing the access to it. So what you've got here is an innovative project that really came on board very quickly through COVID, and it was about understanding the use of public transport data. So we have a system down here called MyKey, and that gives us indicators around the use of public transport. And this is obviously just with the Metropolitan line, but this data in itself could be, is obviously captured historically. It is in one system, but when we sort of think about where this could head in terms of digital twin space, it's around that multimodal transport planning. If a train looks too busy, you might take a different route to work or education or whatever you're up to. And these types of data sets are critical to solving so many more problems, as opposed to just looking at how busy a particular train station is. So these are critical sort of questions that we need to start asking ourselves. How does this data set solve different problems than what it was originally envisaged to do? Next up, I've got, this was actually a Smart City and Suburbs program that one of the Victorian councils right out in the eastern states, which has obviously suffered through some of those brutal bushfires early last year. And this is one of the largest active IoT networks looking at the environmental factors, ranging from pollution to there's some heat sensors in there and all that types of stuff, rainfall, various environment data sets. And this is sitting there essentially in its own environment as a information framework. And whilst it's a brilliant data set, imagine when we put this into other data sets or other data sets in a more holistic digital twin. There's an amazing opportunities there. All the smart tech is already implemented. Clearly, there's some data capabilities in there. So it's about tying all these into one piece. So that's one of my favourite smart city projects. This is actually one that I was involved with. That was with my colleague there, Ben. And when we think about smart city technology and digital twin technology, it doesn't have to be overly complex. This was just a small project that was done to really understand how an intersection or how traffic was being performed. And it was playing out at an intersection, varying from bicycles to people walking through the intersection to obviously cars, small delivery vans, buses, and the like. And when we talk about ecosystems, we don't necessarily just mean digital twins connecting to digital twins. It's actually analytical platforms. And this particular analytical platform that we were using was something that we're seeking to integrate with the actual digital twin. So you can actually take a device using this data capture, and then obviously you have your data outputs that you could potentially load into the digital twin, or you can actually just integrate at the system levels. And that clearly provided us with some really interesting insights, because there's a massive hotel going in there, and we wanted to understand how that intersection was going to be designed in the future. Here's another one, which is a really fascinating data set that looks at wave heights. To me, wave heights are really interesting when you start to look at erosion. You start looking at shipping routes and all that sort of stuff. Now, this data set using a fairly sort of well-known set of IoT sensors that on the water buoys exist, and provides an amazing stream of data. But again, it's sitting there as a discrete data set. It doesn't integrate with a whole range of different digital twin types of platforms. So to me, it's a real big opportunity here where we can start to bring this in. And I've called out, the Smart Beaches link, which is another fantastic smart cities project that a couple of councils up on the New South Wales, Queensland side of things did over the last 18 months, and brilliant project. It starts looking at, okay, if the waves are big, you might start to plan, with your maybe it's not the right time to take some young kids, or I'm not going to drive all the way to go surfing, or whatever it is. There's some brilliant capabilities there when we start to look at combining this type of data with another data set that might exist in the digital twin. And one of the key things that I really was tasked with doing, and I've prattled on a little bit too long around some of the other components, was to talk about some of the future technology trends which are really going to drive digital twins. And one of the primary ones, I think, is the Internet of Things. Those sensors are getting smaller and cheaper. I always use the example that within the next few years, a sensor will be able to be embedded in a piece of paper, and that's it's going to be that cheap and that small. Now, what does that allow you to do in terms of your thought processes around what could be possible in terms of digital twins? The other big one that I think we're going to see is the personal 3D capture, so LiDAR on smartphones. Next version of smartphones is going to have LiDAR on every single model. Now, what does that mean in terms of digital twins, particularly urban digital twins, when you've got a landscape architect scanning a backyard with his phone and then embedding it into an urban digital twin? Amazing opportunities, I think. I think there's the other big one that we're going to see is the maturity and evolution of smart city and smart places. That's when we start to see people thinking about how data can be used, and we also start to have a growing use of sensors and technology. So to me, there's some of the key trends that are rapidly emerging and potentially already here in some instances. Now, I wanted to have a look here at it's not all happy fun times. There are some really big challenges that we have to deal with in working with digital twins. They are some complex pieces, and I've just highlighted a few things here, really to sort of highlight some of the foundational work that state governments and national and federal government and local governments really need to consider. And what we've got here is some work that we've done more locally, and that's around a building that is accurately captured, or reasonably accurately captured, that disappears because the underlying elevation model is not overly strong. So it needs to have fundamental quality data in there and investment in that space to actually allow these digital twins to present and display in a correct way. And it's quite quite a complex project for a place like Australia that's significantly so large. Another really important thing that I always like to point out is, when we think about digital twins and solving city problems and all these types of things, we don't want to fall into that space that web mapping or GIS web mapping fell into in the sort of late, sort of 2000s, when the systems were really complex and no one was using them, and then Google Maps came along and it was just like, wow, that's so easy to use. We need to keep that front in mind. And I'm really looking forward to the presentation that Matt's going to do in a couple of minutes, because some of the work that they've done is really focused on that ease of use and making sure that anyone can pick up a digital twin without really any sort of training. The other key part is when we talk about some Victoria's background, and it's very similar across every state in every jurisdiction in the country, is that the foundational data is two-dimensional by nature. And that is a really challenging space when we talk digital twins, which is in most cases 3 dimensions. So there's a lot of work that needs to happen to convert 2D data to be displayed in 3D format. There's also massive opportunities to take things like stormwater pipes and these types of things that are 2D representations on a map, but actually have 3D attributes, so we can start to convert some of those data sets live. And that's really incredibly fascinating for me. I've shown here, there was an example earlier around Singapore. I've got this map here, and it's a little blue dot on the left-hand side, shows Singapore on the map, and then you've got Australia, and then you start to see, differences in GDP and all that sort of stuff, and the cost to put in a digital twin in this country, whether it's New South Wales, Victoria, or WA, which is even larger, is going to require some really strong thought processes around level of detail and accuracy, because quite frankly, the value in a digital twin is currency. A 3D model that was captured 6 years ago is not that valued as something that's captured at lower resolution, but is highly current. So we need to sort of consider some of those trade-offs. When we talk about digital twins, there's a real challenge, I think, in data discovery. Anyone who's used those open data platforms where there's 3,000 or 4,000 data sets, I'll type in road, someone else will type in street, and there's a whole series of different ways of describing something. So that sort of taxonomy that sits behind data and how we find data is really important. And I think one really strong focus of the work that's happening in this country in the digital twin spaces is distributed data model, which is 100% the right way to go. But what we then see is the need to sort of manage or support and provide standards around what needs to be required in terms of data access speeds, because you can't have data that loads really slowly versus something that loads really fast, because it does become a really interesting user experience then. Now, I just wanted to touch really quickly on the digital twin ecosystems that Marie raised earlier on. And our focus in Victoria is really sort of thinking in that headspace of system integration. And there are so many different capabilities in terms of software systems that do various analytics, whether it's around channel management or planning precincts and all these sort of stuff. There's so many great tools around there. So it's about not having a digital twin that does all these types of analytics. It's about connecting to some of the best of breed things that do exist and making sure that our users and our use cases can easily sort of support these types of systems, because it's a quick way to go from a visualization platform that has different capabilities and get more users and use cases and benefits out of the system very quickly. I think we're going to see the visualization coming through with game engines is really going to take off to a point where that will be the primary method or mechanism that we engage with the community. I think that's some of the stuff, anyone who's following the Unreal Engine work is just sits there in amazement at the quality of that. And I think that's going to be really fascinating to see how it ties in with digital twins. I think the integration of digital twins, not just an ecosystem of digital twins, but I use this example here around if the human body can be a digital twin, with the various sensors that we can wear, all that sort of stuff, and you have something that alerts you connects it to a state-based digital twin that starts talking about tree canopy and all that sort of stuff. Like, okay, you've had too much UV, you might need to move into shade and all these types of things. So it's about connecting these two different systems, which will be really interesting, and obviously that national digital twin discussion. But I've just ripped this straight off the internet, and I'm hoping it flies. So hopefully you can see that moving. But what it's doing now is showing, replace the word company with jurisdiction, or it could be company as well. It could be the academic sector. But what it's showing is that what the digital twin ecosystem really becomes is just a platform of platforms. And I think that, to make those arrows work between those various boxes, it really comes down to that data standards and uplifting the skill sets, and then obviously some governance, leadership, and all this sort of stuff that's critical to make this type of really complex digital twin ecosystem sort of take off. So I know it is a little bit simplistic, and I might sort of move it to a next level, because I do quite like the way that it's presented. But like I said, the key part is to really think about it as not one single digital twin. It's actually about connecting digital twins, and there are many different elements that we do need to consider when we do that. I've just got my details up, and I know that we're going to sort of jump into some demos that Matt's going to provide, but please feel free to reach out. I've got a couple of different hats on there. So, local government members, etc. from ASCA, please reach out. I'm happy to have a chat about some of the work that ASCA is looking to do in the digital twin space, but also from a Victorian perspective there. I've got my DELP email address, and obviously I can be reached through LinkedIn is my most commonly used social media platform. So I'm going to hand over to Matt for what I assume will be the highlight of the show. It's some absolutely fantastic work coming out of Data 61.
Thank you very much, Alan. Just before we do, Adam, we've got a question that's come through from James Senka. James, would you like to come off mute and ask your question?
Thanks, Adam. I guess my question to you in relation to what you've just presented is how are the local government authorities embracing that data maturity that's needed for digital twins? From your experience, what's your sense out there of the current state?
Yeah, look, James, that's a fantastic question. I think in a lot of ways, I think local governments have bounded ahead in a lot of the sensor technology, whether it's smart parking and smart bins and these types of things. So they're starting to think in the data space, which is really, really important. They are incredibly lumpy in that digital twin component in terms of GIS mapping and all that sort of stuff. You've got some that are a long way ahead of others, and then you've got some that are really still sort of in that infancy. But we also have to recognise that local government is one of our big leaders in open data. They actually moved down that space in a really rapid way. So whilst I don't think their maturity in the digital twin space is where it needs to be, I think they're pretty well positioned. And these types of masterclasses, and it's one of the reasons why I got involved, is that ability to information share and then get different local government leaders to connect to each other as well in the digital twin space.
Adam, there are a few other questions which have come up, but I personally reckon we should go to Matt's, look at the demonstration, and then go to a Q&A.
Okay. Thank you very much, Adam. That was fantastic. There are so many things in there that I'm going to touch on as I talk and show some things here. And some of those questions, obviously, which is exactly what I was going to say when I came off mute. I think there's some questions here that we need to answer because these questions are really good. But we'll do it later. Okay, I'm Mats Henriksson. I am the group leader for the Web Geospatial Systems Group. We're a part of the engineering and design program at CSIRO's Data 61, so the data and digital arm of CSIRO. I work side by side with Marie. I manage the technical team to deliver our approach to digital twins, while Marie manages all the product and the stakeholder engagement and talking to people and things like that, right? So. So Marie and I work very, very closely every day. So in my group, at the moment, the main thing that we're going to talk about today are the digital twin work. So at the moment, we develop and run digital twins for New South Wales and for Queensland. We run many, many other simpler maps, I guess we could say, of the same technology, Teria, which is the technology we've been working on since 2014. The national map, the national drought map, a bunch of others for various different governments, state governments, international governments, things like that. In my group, we also develop and operate part of data.gov.au. Again, this has all come together to create our digital twins. So what I'm going to be showing today is our approach to digital twins is Teria and Magda together, the two techs that we develop. They're both open source. The majority of work we do is open source and based on open source, because the money in most cases that pay for this stuff is taxpayer money, government funded, they're government funded projects. And so we need to give that back to the community effectively. So I'm going to share my screen and see if I can get going. Everything I'm going to show today is live, so there could be some comedy here as well, as frequently happens.
I'll join in to help you with the comedy.
Thank you very much.
And I'll just make a comment. So I'm going to help Mats along here as well. Mark, if you wanted to share in the chat, we've put together a bit of a share link with some open data, and you can click along or save it for later. A lot of the data that we're going to show today is open data, so you can access it today and you can use it. So you can let us know how you go with that as we go as well. So back to you, Mats, but I just wanted to share that.
Awesome. Can you see my web browser?
I can, and it says good afternoon.
Cool. So what we have built is a digital twin system, our version of a spatial digital twin. It is open to the public. That's how we want it to be, and There's a bunch of choices that comes into that we can talk about as well. And so anybody can hit, open up a new tab in your web browser, type in New South Wales or Queensland, which we'll get to later, and you see this, right? This is the live system. Anybody can use it. It has an extensive catalog of open data. You can also log in. You can see I've logged in here, so I have access to some other data that I'll be showing off. So this is an open source system. It is using Cesium. Some of you may have heard about Cesium. It's a web geospatial visualization library, right? And so this is what we use to show things in 3D, right? There's a bunch of tech around that for IoT, for format conversions, all this kind of stuff. But the base of it is all, we use Cesium, and we have a very good partnership with Cesium. Again, Cesium's open source, so we're feeding into that kind of open source ecosystem. But in order to show all the things I'm going to show, I have prepared some of our story links. So again, this is still a live system. These are the story links that you can send in an email and share with friends and co-workers, collaborations, all this kind of stuff, right? And so this is one of the main uses, I think, of our type of digital twin, which is sharing with users, sharing with community, sharing with collaborators and things like that. So going back to what Adam was saying before, when he was showing the map of Australia and how large Australia is compared to Singapore, the decisions that we have made from that is we have gone broad in our digital twins. We've gone very broad when it comes to data sets, data coverage, access, and things like that. And so we have a public twin with a lot of open data that covers large areas of Australia at the moment, hopefully the world in the future. So New South Wales and Queensland, going broader, hopefully. Adam also mentioned National Digital Twin. There's a discussion going around about that, right? So our use cases are broad use cases. They're for general users. They're for people to be able to pick up. You don't have to install software. You don't have to install, anything like that. You can just use a web browser or your phone or your tablet or whatever it is, and it will just work, right? That's the whole idea. It should just work. You should be able to look at the things you want to do. If you then want to grab that data and stick it into ArcGIS Desktop or QGIS or whatever platform you have locally, then that should be possible, right? You should be able to integrate these data sets into the work that you do day to day. But for now, I'm just going to show some visuals to get you an idea about what we're doing.
So I think where we're starting here, I use some of the fundamental digital twin data sets, and Adam touched on it. They're the foundation layers of a digital twin, and traditionally they've been 2D geospatial data sets. But what we're going to show you now is sort of the emerging sort of what everybody will have first of the 3D sort of data sets to represent, closer to reality what our urban environments will look like. So back to you, Matt.
Yep. And so the first thing that most people have is a photo reality mesh, right? This is a 3D photo reality mesh of Parramatta in Sydney. And so it's a 3D scan effectively of that part of the city. This highlights a bunch of technical things here. So for instance, when we zoom in here, it will first be rough and unresolved. And then as we're looking at it, it will improve its resolution. Now, that's because we are operating in a web browser, right? I'm not going to be able to transfer this entire data set, which is, I think, a couple of terabytes, to my browser so that I can see it in whole, right? I can only transfer the bits that I'm currently looking at, and I can only transfer them in suitable levels of resolution, level of detail, LOD. And so as I move around here, my web browser goes and says, oh, I need a high resolution tile at this place so that we can look at these trees and these buildings, right? And that's how the whole system performs. We can only send pieces of data, not the entire data set. So everything has to be streamed. That leads to a bunch of different choices when it comes to data formats, how to collect the data, all this kind of stuff, right? And they're really hard problems. They're like research grade problems that people spend years on. And it's only in the last few years that what we've seen here is 3D tiles. It's only in the last few years that 3D tiles have come out, which is currently considered to be one of the best streaming data formats for 3D. And so that's what we use for pretty much all of the 3D data that we're going to be seeing today. In New South Wales, they covered a very, very large area of New South Wales. So we've got Parramatta, Sydney West, all of these different parts of the city that they've gone through and done 3D scans of. And so I'm not going to show off all those because it does take a while to load, which is why I've preloaded these in the tabs. You'll see that when you look at your share URL later. So that's the first thing usually that people look at. The second thing usually comes down to buildings, 3D extruded buildings. What we're looking at here is a fusion of geoscape data. So geoscape building used to be PSMA. And augmented with roof lines that you can see. New South Wales have gone out and done LiDAR scans of a lot of these areas, and they've augmented the PSMA data, the geoscape data, with roof lines. The kind of easy to do use cases that you can do once you have this data, right? If I go and I turn on the timeline here, what I can do is I can drag around and we can see what kind of shading you have, right? Depending on the day, it has an accurate model of the solar system, so it knows where the sun is, it knows where the season is, all this kind of stuff. And so we can change the day here. At the moment, it's today, this is basically what the shadows did today from these extruded buildings. That's a very good way of simulating, okay, I'm going to build a new building, here's what it's going to do, here's the shade it's going to put on the park next door or the neighbors or whatever it is. And speaking of that, what you can do with this, so we're still in Parramatta, this is the theatre. What we can do here, maybe the theatre is old and we need to redevelop it. And so we're going to remove the theatre, maybe we'll remove some of the other buildings around it, right? And then we're going to drop in our own model. Now, let me add local data. So I'm going to drop in this model here. So this is from my desktop. You might not have seen that window. I had a file window that I could choose files from. And so this is a file from my desktop. I can put that, let's put it somewhere here, pretty much where the theatre is, right? We'll spin it around. Oops, now we can't see. We'll spin it around. It's going to be placed like that. Move it around a little bit. And so what we want to do is have this system. So there we go. So now it has a nice view of the river. It's a simulated, architected building, Minecraft building with Minecraft trees, right? But that's how easy it is for me to take my own data, upload that into the system and see it in the context of all of these other buildings, right? And then we can, again, turn this on to cast and receive shadows. And now we can play around with the shadows again from this new building, right? And so that's how easy it is to do one of these planning use cases. Now, our end goal, we're just at the start of this. Our end goal is for this building to be uploaded into your user, storage space. You can do a share URL of this so that, you can send that via email to your friend or colleague or community consultation, whatever it is. Write a story about it like we have here. So that's the first two data sets usually that people want to see. They want to see a photorealistic mesh, they want to see the buildings, right? And they want to be able to play with that. Then the next thing is live data. People want to see live data. They want to see your transport data, your buses, your trains, all this kind of stuff. And so here, again, it's quite a lot of data to load. So you see how it loads that data on demand as I go through these views, right? This is the bus station in Penrith. And so what we have here are a number of buses. What you see here on the left, every 5 seconds, we get a new position location for all these buses. And if we zoom out, we'll see all the buses in Sydney, right? At the moment, these buses are probably standing still because they're at the bus station. I can click on these buses and, it has many seats available. It's currently not moving, so it's going to stay there. We can probably find other buses further into town, right, that will be moving and maybe have, people on them. Amenities available, it's moving slow down the street. There you go. You just saw it move it, right, every 5 seconds. And so this is, again, now we're connecting to the real state of the world, live state of the world, and we're showing, we're doing a more accurate twinning, right, of what the world actually looks like. We're hoping to be able to have, historical bus movements or potentially future bus routes, right? At the moment, this is a demo. We're showing buses. Nobody's going to use the New South Wales digital twin to figure out when they should go out to the bus stop to catch the bus home or something like that, right? But it's a proof of concept, a use case where we want to integrate this kind of live data. The next thing, building information models, and I'll show two. I'll show one here, and then I'll show one in Queensland as well, which is a little bit more complex. So this is a train station up in Newcastle, and so this is a BIM. Marie is better than me to talk about BIMs. This BIM comes directly out of an Esri portal in New South Wales, and we converted it on the fly into 3D tiles so that we can see it. BIMs are very, very detailed, can be very, very detailed engineering drawings, CAD models of things. And so we can click here, we can zoom in and we can click on the stairs. It's a stairs. It has whatever attributes they've put into this model, right? We can look at the fences, we can look at what the view is, all this kind of stuff, right? This shows the kind of scale that we can go. So we can effectively zoom out and we can show the world, and let me just adjust the lighting here a little bit so we can see it better. We can zoom out and show the world, or we can zoom in and we can effectively show the buttons on the payphone, right? That's the kind of details that you can go in. So if we just move that a little bit and then we can zoom out, and now, we're showing half of Australia or back in. So that's the kind of scales that we can talk about, which is means that we have very, very large coverage of different use cases. We can do so many different things. Like I have a demo file where I show satellites orbiting and then cut to the payphone buttons, right?
Yeah, and I think the only thing to add before we move on, or we can move on and I'll still say it.
Yep.
So we talked about sharing data from infrastructure projects, or Tim's certainly touched on that with great authority. And I think the interesting one with that BIM file, it's been shared as open data from Transport for New South Wales, but it certainly sort of highlights the possibilities if we can have this, if there's possibility and the infrastructure in place, governance, etc., to be able to share these between projects and different parts of the life cycle of those assets. Anyway, so the tech's coming and there. It's the other things we need in place that Tim's working hard on, I'm sure.
Yep, that's right. So here, another use case, environmental monitoring, right? So we have air sensors in Sydney, and so we can see the current state of the air quality in Sydney in various places, or further out throughout New South Wales. This is another IoT API effectively, where we can get all the historical data from these air sensors, and people can incorporate these in their modeling and do predictions and things like that, right? Together with the data that underlies here is urban vegetation cover. So the percentage of the area in these areas that is covered by all vegetation. So trees, grass, bushes, all this kind of stuff, right? And there's various different types of analysis that's been done, right? Different kind of layers these are all output from a scientific research process where they've basically flown an aircraft. They've been photographing with IR sensors to see where there is green vegetation and where there isn't. And this can be used to inform, how much trees should we be planting? Is there an urban heat island? Things like that. Other layers that we can show, right?
Yeah, and I suppose the key point there is it's an output from an analytics process.
That's right.
So we talked about ecosystem, and Adam mentioned not necessarily digital twins connecting with digital twins, but other analytics platforms and processes. And that's exactly it. It's a 2D data set, but that's what it is. It's an output from an analytics process or platform.
Yep. Other thing, this is very relevant to what's happened in the last few months. It's very easy to incorporate these 3D things with 2D data, existing processes that have been around for, 20, 30, 40 years. And so here, for example, we have near real-time historical imagery of, from the Sentinel satellite. This is showing Windsor in Western Sydney. And what we have here is 2 dates, one pre-flood, and then we've got the March floods here, right? And so we can see exactly, where it flooded and what happened. And so this is just showing the ability to hook up these existing things to new things, and you can get more insight here. We could add on the buildings here, and we can see which buildings were actually flooded, right? And so here comes down to, again, we've tried to make it as easy to use as possible. And so we have, big loud buttons. We've got these time controls where we can go forward and back, and we can, filter down exactly what times and dates and things like that. Trying to make it as easy and easy to use for people as possible, right? If we move on, also connecting, we can view these in false color, and now we can see even more exactly what the flooding looked like. And so it's very easy to turn on these different analytical features, different ways of visualizing things is where we want to go. It all depends on the underlying data formats, however. So we can do this because of the analytical features that are available for these data sets. And so for some others that are in a different format, you might not be able to do all that kind of thing. Probably worth highlighting here as well that the data I'm showing today, none of it pretty much, we don't hold this data. It's a federated system. And so when I'm looking at these data sets, this comes straight from Geoscience Australia. If we scroll to the bottom, Geoscience Australia provides that data. If we look at the Waratah station, the BIM model we just saw, that comes from New South Wales, and so on and so forth. My computer, as I look at these, which is why there's, when you zoom, it takes a while for the images to resolve. My computer, as I move around, is reaching out to these data services and getting it in real time. It's not held by CSIRO. And so we really want the data to stay with the data custodian so that they have the control of it and can update it and things like that. Let's have a look at Queensland. So again, very similar. You see it has the similar kind of interface. It's all based on the same technology stack that we have. And so here we've got another BIM example, a bigger, much more detailed BIM. Oops, it's probably reloading. So we saw the BIMs. They can be very, very large, right? There can be a lot of data in those BIMs. Let me do that. And it can take a very long time to load, as that BIM does. Now, probably what I didn't show there was, now I've got this little padlock here on this data set. This data set here, which is the buildings, there's no padlock. This one here, I've got a padlock because I'm logged in and I can only see this underground infrastructure because I'm logged in, because I'm authenticated. And so if you send this share URL to somebody who is not authenticated, you'll get an error message saying, sorry, you can't look at this thing because you don't have access effectively. So what we're looking at here is we've got the Woolloongabba, the big stadium in central Brisbane. We've got one of the intersections there, and underground, so I can shave away the ground, we have the infrastructure, right? And so if we zoom down even more on this intersection, so what you can see is the tops of these utilities sticking out effectively, just to kind of show where they are. And then I can shave away the ground and we can see, exactly what they are. We can click on these and we can get the attributes out. So that's not a good one because it says unknown. Energex, so this is some kind of energy utility, probably 1500 mils. It's made of PVC. It's at 0.51 meters below ground, right? And these others, some of these are Telstra, and so on and so forth. So we can interrogate this data and we can view it in 3D. We can see exactly what its relation is to, in this case, aerial imagery. See the bin sticking out kind of thing. It could have been boundary information, which is one of the other ones we show on here usually to show boundaries and exactly where those utilities are. That gives the power. Again, this data comes from different places. The aerial comes from different places to where the buildings come from, to different places to where the underground information is. So it becomes a context thing, right? We load everything and we show it in context. So here is where we get into some of the kind of R&D that we do here at CSIRO. This is a CSIRO site in Brisbane, Pullenvale, where we have connected to the building management system, so to an IoT system effectively. Here's where we can talk about the ecosystem of digital twins, because a building management system can be very, very rich. It can be a digital twin of a building, for instance, right? And so here what we're looking at is an extract of that building digital twin, that asset digital twin. And we're getting some particular data series out of this digital twin. And in this case, it's the solar panels. And so when I clicked there, my computer on my desk in front of me reached out to this IoT system, and it grabbed the power generation from the solar panels on the roof there. And so these are the last 7 days of power generation from those solar panels, right? And we can click on these others and we can get the power generation for some of these others, right? Now, here is where things got really interesting for us in digital twins, because there's not really any protocols for dealing with this at the moment. There's no way of connecting IoT systems to 3D points or 3D spaces or 3D assets at the moment. And so we worked with CSIRO, with some CSIRO researchers, and we figured out, okay, well, we have this time series. We want to connect that to these 3D objects that we're showing, and we had to figure out how to do that effectively. And so there's still, we talk a lot about digital twins, but there really is a lot of things that we haven't figured out how to do yet. And so we're still working out how to do everything, it's really interesting. You'd think that everything would be solved, but it's not.
So Matt, I'm just conscious of time.
Yep.
Ian, let us know if we need to wrap up.
I've only got another 3 scenes, so I'll be quick.
The 3 things? Okay, cool.
There are lots of questions popping up in the chat, so people are really keen to ask you.
Fantastic. And so here again, we're talking IoT. We're working with CSIRO Research. They have instrumented the Gateway Bridge in Brisbane, and we'll zoom in on that a bit. And so what they have, they've instrumented 3 bridge spans, both sides of the road on one of the bridge, because it's a double bridge. And here I can click on this. I can get the time series data of traffic effectively. And so here you can see, middle of the night, 3 a.m., there's very little traffic, and then 6 a.m. rush hour starts, and so on and so forth. This is the accelerometers of the bridge, and there's about 80 different sensors here. And so we can add on different time series and we can compare them, kind of thing.
Yeah, and I guess the point with this one, this was the very early proof of concept. Again, we're just trying to bring together the different data in the system. But the ambition there with collecting those accelerometers and the other data was to build models using machine learning, other things, about how the bridge operates under normal circumstances, and then obviously use the live data to test that. So that's kind of the use case where this was going towards, but this was kind of the first step in that proof of concept.
Yeah, and here as well, these rectangles, they change color depending on what the values are. And so as things change, it'll go green, it'll go red, hopefully not red, right? If there's an earthquake or something, but yeah. And then the last one, let me put that on both. So here again, we've worked with CSIRO researchers who work in natural hazards. Let me turn on a different base map actually, so we can see it better. This is extruded buildings. We got the GABA up here again that we looked at before with the infrastructure. This is flood modeling. And so this is a flooding event effectively that they looked at. They modeled 24 hours. So we've got, Friday at 1 o'clock on the left. And then we have Saturday at 4 o'clock on the right. And so we can see how the flooding has progressed. And this is all research output, right? Modeling, prediction of what would happen if you had this much rain and so on and so forth. What they've done here as well is they've actually included the buildings in their hazard modeling because the buildings change the flow of the water. And so we'll see that basically the water, as we look underneath these buildings, the water goes around the building and it changes how fast floods happen and the speed of the water going downstream, things like that. And we can, play around and we can move forward in time here and see how it changes hour by hour effectively. And so we've added interactive controls to this model in this system, showing different data from different sources, showing the flooding together with the roads, for instance, together with the buildings, all coming from different places. And so here's how we're showing how you can connect to analytical outputs to modeling and show that in the same platform effectively. So I understand that I'm at time.
Thanks, Vance. I've got to say that was extremely interesting. And folks, what I'd ask you to do is put your questions into the chat. There are a couple of people who've been very patient with their questions so far. And Ilse, you've asked a few questions along the way. Possibly the most important question out of the list you asked might have changed after seeing the demonstration. Ilse, I'd encourage you to unmute and ask the question you think is most pressing now that you've seen the demonstration.
Hello, everyone. I think thank you for the fabulous presentations. Really enjoyed it, having watched this scene for some time. Perhaps the question I'd like to ask relates to what extent does the digital twin discussion encompass the cyber security issues and how that's being approached in Australia? Yep.
So that's a really good question. Obviously, yes, that is a big concern, right? So when we started out, we made sure we only have open data, right? Because we're open data, that's our bread and butter, effectively. So we started out with just open data while we worked out, what is the security implications of sharing data and how do we do all this kind of stuff. So for instance, the way we worked it out with New South Wales is the majority of the data, and certainly the data that isn't open, sits in the New South Wales S3 portal or other sources. And there's an authentication authorization process that happens. There's a key and token exchange that happens to ensure that I can only see that data if I have permission from New South Wales to see it effectively. So again, that's one of the reasons why I actually don't want to take their data and host it, especially if it is sensitive. I'm going to leave that to New South Wales. They have processes and policies and all this kind of stuff in place for that, right? They have a security team and they should be responsible for their data. I only get access to that data if they said that I have access to it. And so there's actually a bunch of data on the New South Wales Digital Twin that is accessible to some people, but isn't even accessible to me, even though it's, it's my system. I built it, we built it, our team built it, right? I can't look at that data because I don't have the right security token. I can't see it. And so, yes, those kind of cybersecurity issues around access have obviously been very much something that we've been considering and figuring out how to do the right way. There are other cybersecurity issues, of course, things like if some data gets shared inappropriately, maybe New South Wales makes the wrong decision about who should have access. Maybe somebody who shouldn't takes data and makes it public. They share a screenshot, or a video, excuse me, and say that gets shared with terrorists, right? Those kind of cybersecurity issues are the same cybersecurity issues that already exist in states, in Commonwealth, in LGAs, right? They already have to have procedures for classifying information, for ensuring that it's released to the right people. Mistakes can always be made, right? And then we need to work on fixing those mistakes. But just because it's available in the digital twin doesn't mean that we are more likely to make mistakes. We need to have the right processes, procedures, fail-safes, all this kind of stuff in place. But just because we have digital twin doesn't actually make things worse in the world. We're hoping to just make things more efficient, productive, all the stuff that Tim talked about, right? To ensure that we can be more productive as a country.
I think the other point to raise around security is obviously the sensors and the requirement to have secure sensors. So that's outside of the concept of secure data. If someone was able to hack into a sensor device, they can then start to really, change the way that a city functions, change the traffic lights and or whatever it is. So there's a real requirement, and you're starting to see that come through a number of jurisdictions when they're looking at secure by design. So you're actually separating out, traffic lights so that, someone doesn't bring down the entire traffic light network. It's actually only going to influence a small portion of the network. Or, there was that case in Florida, which I actually found really fascinating, because when someone tried to contaminate the water, and it was actually through really, really strong security practices that they were able to capture and prevent essentially a terrorist attack in terms of contaminating water. So, there is those elements of security that really come into play, not just obviously the digital twin platform component.
Thanks very much. It's a very broad issue and a very, very big issue, and I think there's also a role for developing standards in the cybersecurity space to help. Now, Teresa Anderson was also asking some really interesting questions. Unfortunately, Teresa had to leave, but I might still ask the question on her behalf. She's asked the question, how can digital twins help to bring project planning questions and data exploration to life? And also curious as to how we can remain aware of the possible risks or limitations of data inaccuracies or incomplete missing data. So it's a different sort of question, the one Ilse just asked, but there's certainly a data completeness quality aspect, and then specifically applied to the question about bringing planning or project questions to life.
I'll take this one, and I think Adam will probably stack in behind me, to be honest. In early days around discussions about digital twins and federated data sets, there was always, so it's back a step, it's absolutely something to consider. And in many respects, the comment earlier about garbage in, garbage out is absolutely the right conversation. Again, in line with the security one, it's not a reason not to try. It's just being aware effectively of what those idiosyncrasies or gaps or granularity issues is in the data, and what happens when data source 1 with gaps X is multiplied or overlaid over data source 2 with gaps Y. And I was a big advocate, at least with the Victorian government. I think that'll be carried forward, and I think the data houses of the major jurisdictions are starting to crack this nut, which is fantastic to hear, is around a data decision quality index. So it's taking all these elements together, whether it is spatial accuracy, where it is granularity, where it is quality of data, where there is polling levels, and taking all these elements. And then basically, there's heaps of ways to skin this cat, but effectively providing red, amber, green around what that decision quality is, and then multiplying it out. And let me give you a classic example in probably like a real world context. If you're a doctor and you came to someone's bed and you read that their blood pressure was through the roof, but then you didn't know that blood pressure reading was from 15 years ago, your actions would be completely different to if it was 5 seconds ago. So the same applies from a policy context and planning context. If you don't know those idiosyncrasies of the data, of which you may not own or to be the steward of, then you may end up making the wrong decision. So it's absolutely a concern. I think as digital twins will progress, as will meta information that underpin the data sources, to allow people to make that informed decision making when you are federating a number of things.
Great answer. You said metadata. You got my attention. Anyone else like to add something to that response?
I think one really important point to raise is that data doesn't always have to be as accurate in different circumstances. So I use the example of 3D buildings. Now, if a 3D building is representative of a cadastre, so a multi-story building, then it has to be that the 3D building has to be really accurate, or it's going to completely misinterpret what the legal description is. But then a building out in 200 kilometres from Melbourne CBD and it's on a 50-acre property, it doesn't actually matter if it's out by 10 metres. I mean, you want to be notifying that there's a building there, but it doesn't have to be accurate, geographically located. So we need to be really careful around setting accuracy standards that get to a point where they hold back the cost of creating new data sets, because it's just simply too expensive. And we need to really make sure that we can target that accuracy level to the use case. And I don't think anyone ever sits there and deliberately has inaccurate data. But accurate data is actually really expensive in some cases, and we need to make sure that we're balancing the level of accuracy with the cost benefit component.
Sorry, Maria.
Yeah, I was just thinking a couple of observations that we've made on the journey. The first is you don't want. I want to pick up where Adam left off, and that is the fitness for purpose, I think, is really core here. And then the second part of it is we know that if an unreasonable or a high expectation is set around metadata or standards, it can become a barrier to sharing data or even letting people look at it in the first place. So I suppose we just want to have a balance, and I think it's kind of that policy decision is how do we uplift literacy and to enable people to publish their data that has basic standards in place around metadata and sharing. Otherwise, you're just implementing a barrier. So it's all got to be put together in nice ingredients to make a really highly functioning data ecosystem, I think, is what we're after. And so the barriers are something that we want to avoid.
Can I add on this? And hopefully it's a sort of a balanced conversation. I actually think the metadata will actually facilitate more sharing of information, because I think ultimately it will give people who own these data sets a degree of comfort that people that are using the data sets will be more informed about the outcomes. And in many respects, it's a function of good government to be transparent about what you're doing and what decisions are being made. And I think ultimately without that, people aren't comfortable because they're not that comfortable with the data use or the outcome of which you're just deciding to use that data with. So I think ultimately it could be a double-edged sword, and at least from conversations that I was leading, people were really happy to share the data within government, but they just really wanted to know what the use case was. And as long as they had that on paper and obviously IP and that sort of conversation was managed, licenses were happy to be transferred for certain use cases. And so I think, I could see it being a double-edged sword. But I think transparency is the name of the game. So
just from our experience of running things like data.gov.au, there's 100,000 data sets or something like that on there. Mostly government data sets, of course, tens of thousands of users every month that look at those data sets. The comment that we get from people in the industry, TomTom goes on there to find location data, the gazetted list of locations for Australia, things like that. As professionals, most of us here are connected to GIS or connected to, one of these professional things where we really think hard and we care, rightly so, about accuracy of data. Overwhelmingly from the users, what we hear is, yes, accurate data is fantastic, but if you don't have accurate data, just give us whatever you have, and that's better than nothing, right? As professionals, we are very afraid of releasing data that is not accurate. But as the users, they just go, I just wish we had some data instead of nothing. And so I think there's a balance to be had for sure. And
I think the case in point of that for that, Matt, is, to be honest, is like something like Google Maps. I think most spatial people I know, geospatial people, cringe at how much people use Google Maps. It's not accurate, but it serves a very really and high functioning purpose. And if people are happy with that trade-off, they're not using it to measure, to a high degree of detail, building envelopes or anything like that. They're using it to get from X to Y. And if you're off by a meter, so be it.
That's right.
So it comes back to that use case in all these conversations. And to be honest, in that transition from BS 1192 to ISO 19650, that's exactly why the whole term of level of information need, or LOIN as they hate it being called, came out. What do you want to use it for? Because that really determines ultimately what you're procuring and what the quality of the information is in the first place.
I'm going to throw to another question, in this case from Simon Hunter. But before I do that, Tim, you brought up standards, so I'm going to blame you. Just to put in a plug that Australia is actually leading the charge for the JTC1 SC32 Working Group 6 work on data sharing and use. And throughout that entire data life cycle, we are talking about The extra metadata we'd need to package along the way to be able to determine quality, and then that fitness for purpose for particular use. And a plug for Data 61, it's the Data 61 folks who are talking about the use cases generically for data and trying to match quality versus use case. So there's a lot of common threads to this conversation. But Simon Hunter, over to you. You've asked a few questions. And again, given how the conversation has evolved, would you like to unmute and ask what you think is the most relevant question now?
Thank you, Ian. Let me start with a comment. I could listen to you guys all day and half the night. This has been a great session, and I genuinely appreciate it. Disclaimer: I sit on a board with Adam, so I'm saying that genuinely and not because of that. Look, my challenge was more: how do we best make the case for investment in these through use cases? Like, I'm a recovering transport planner, and I love the point about the bus data and historical bus data and things like that. But when I want to make the case for multi-billion-dollar investments for engaging with cyber risks and things that come from data and these systems of systems, I feel like we need to have a really strong, what is the use case, what is the decision this will inform, and how will it deliver the benefit. The second part of my question is, what do you think the realistic nationwide cost is, and what's the ROI in years, so that when Tim Mumford makes this recommendation, I hope in his next hard-hitting publication, we have a case for investment and a realistic estimation of when the return on investment will mature. Sorry, Ian, a number.
So I can come up with a quick just one point of data here, right? Singapore, Virtual Singapore was $73 million. It took them 5 years to build. And that's for an area the size of a postage stamp compared to Australia. I'm not saying it's going to cost us, order of magnitude more than that. I'm just saying that it costs money. It does.
So it's a good question, Simon, and I dare say if you were on this side of the fence, I think I'd be saying the same thing about listening to you all night. So at risk of boring everyone for us talking overnight, I think it's a really interesting question, and I think it's probably a rare insight into both of our day jobs in many respects. I think it comes back to that third point, which I was articulating about quantifying the value of data, and it comes back to the use case, to be honest. And I think we need to hook our teeth into absolutely valid problems that the government of the day struggle with, whether it is bushfires, whether it's cladding, whether it's asbestos, whether it's data being transferred for the cases of COVID. I would say never waste a crisis and seek those opportunities. I think it's also paired, that reality is also paired with, I think there's a general recalcitrance against IT projects, and they're bundled in here, to be honest, which is a bit of a shame. And how they perform, I think there's a bit of a risk with that. I think there's a bit of fear and unknown, and I think these things are just sort of so black boxy that they're hard to grapple, and so it's easier to just keep the status quo, whether it is planning, whether it is BIM, whether it is digital delivery of infrastructure, whether it is new shiny infrastructure that people have never heard of, let alone blockchain, which is you sort of got to be in a new state of mind to quite understand in its entirety. So I think it's a bit of the fear of the unknown, of the unknown about how they perform, and everything in between. I'll leave you with this, but I think it comes back to sort of outcomes-based investment. And the reason why I say that is, I'll just leave you with a bit of a thought. Level crossing removal authority was based on two investment cases. One was around dwell time and the other one around safety. The level crossing removal authority had safety dwell time numbers around like how long people were waiting at lights. And it's been, I want to say something to the effect of 7 billion on some of those dwell time numbers. I dare say if you make a cheeky little business case on the GPS units in any bus network or any network, and then you calculate the dwell time, which I did in southeast Queensland for that bus network, the average dwell time for the bus user there is about 5.5 minutes by about 1.5 million trips a year. And if you calculate someone's time, even at minimum wage, the BCR of this thing goes through the roof for a cost of a GPS unit. So I think there's a lot of quick wins out there, is what I would say. And I think people's time is precious. And I think we've got to seek those opportunities. And then eventually we get past this sort of momentum where this stuff is unknown and risky. Because I dare say, the 73 million that Matt's articulated, tell you what, if you had have said to someone politically 10 years ago that you had had a system that knew where all the cladding was, that there might be a risk in the future, they would have made that $73 million commitment. I'll give you the hot tip.
Any other responses to Simon's question?
I think one point we haven't really raised, and we all come from sort of government-based agencies or research groups, is that we're not working in a vacuum here. There's a lot of fabulous data sets that can be used from the private sector. Whether it's telco data all the way out to we've spoken to private organisations who have building height envelopes across the whole eastern seaboard of the country. Now, we can actually use these types of data sets through various types of partnerships, and at a very sort of quick fire way, i.e., populate these digital twins quicker and cheaper than what would it cost, because we're not repeating this same approach multiple times. And I think having that concept around a national digital twin or a state-based digital twin is not just about connecting the data sets, but it's about putting the whole innovation sector on a single platform or a single space or a single thought process where the standards and all that are equivalent, so that we can roll these things out much, much quicker and cheaper than we ever imagined if we were doing this by ourselves. I don't think the government is doing all this by themselves, and that's when you look at some of the stuff that Data 61 are doing in a platform, it's actually open and expandable, so that these things can be built out and different use cases can be taken on board. So, in terms of how much it's going to cost, I think it's always important to remember that Singapore were pioneers, and we should be learning from some of the lessons that they had.
Great, absolutely great point, Adam. There are a few more questions coming in, and some of them get to the point about just how far digital twins are going to go. So we've touched on it a couple of times. So the questions about going beyond buildings and talking about citizen experience by linking other sorts of different sorts of data sets together. A great example with sensors and devices. But if you can digitize it, potentially the sky's the limit. Let me ask you the question, and then we'll go to Rita. Ask the question: what's the roadmap for digital twins? Do we have a national roadmap for digital twins?
That's what I'm advocating for, Ian. So watch this space.
Well, that's really good. So that's great. You got my vote. How broad do you think the digital twin maturity model scope of engagement could actually go? I mean, could it actually deal with citizen experience?
Absolutely. There's no difference. I think if you look at marketing and digital marketing, that's a kind of good analogy. There's amazing platforms and scripts out there where you can follow users on websites and follow how they track over time. You can do A/B testing. There's no reason why that kind of philosophy can't be applied to digital twins and see how people use them, whether they be policy, whether they be individuals, I think everything in between. So we might be able to, through machine learning or, for something slightly more agricultural, be able to find out effectively how people use it, and those organic BAU cases will flesh out and there'll be stories around that. I'm not sure, but I think Ilse's comment's a good one. Maybe we do need to pound the pavement and work around the departments and agencies and people and find out what those absolute use cases are. Because I think a bit of it is build it and they'll come. And I think that's been the philosophy, which has been okay. And I think now that we've built it, now we've sort of got to take it to them and see if they will come and find out those use cases. But I think by and large, I think the sky's the limit, Ian.
Sounds good to me. Rita Arrigo, I'm going to ask, was your question, which was asking about the citizen experience, would you like to refine the question or do a follow-up?
Sure. I think what I was trying to get at, and a great example was when you were talking about, Adam, the smart barbecues in your council, and you were saying that, you know, you learned about data, but imagine if that data could be made available to citizens to be able to book barbecues or be able to know if they were available. And it's all those kind of things that when you open it up, the kind of experiences you can create for citizens if they can access some of this digital twin data in a familiar way, I suppose. So I'm just wondering whether that could be a way to help bridge this need that we have for investment around these digital twins.
Look, it's thanks for recognising the value of that application there, Rita. One thing that's really important to point out that we experienced at Wyndham and, you know, a number of other local councils, certainly possibly all of them, was the work that needs to happen to operationalise some of this type of smart technology. So, you know, if you talk to anyone who's put in smart bins, the bins are effectively, in a lot of cases, just dumb bins in the sense that they've got technology embedded in them, but people still just go around collecting the bin at the same time every day. I mean, that's not what the purpose of this type of technology is. So the technology works brilliantly, but you've got to be able to make sure that you tie up that people element of, you know, the people technology process type of triangle that we always talk about, and make sure that you're operationalizing these outputs. And that's where I think sometimes digital twins are fantastic, because it can be an automated type thing. So if someone walks into a room, you turn the lights off type of stuff. So there's all these types of capabilities. So yeah, there's definitely a lot that needs to happen beyond the data and the technology side. And the best, certainly what we did at Wyndham, which took some time, no doubt, including the development of a smart city strategy, was to spend time with the executive groups to make sure that everyone was on board that process, to make sure that there was adoption and the operating type of elements that came into it, whether that's through, you know, mowing based off, you know, rainfall, whether it's through cleaning the barbecues, or whether it's through, you know, investment that needs to happen to, you know, fix a drain that's clogged. You know, it's about making sure that everyone from the field crew right up to the executive understands what this technology can and is doing. So, and also to kind of make a concrete example out of this as well. So for years, we have been providing a data set with AMO of power station generation in Australia, right? And so you can look at individual power stations and you can see how much they're generating on a 5-minute interval, and you can see the time series of how the generation happens. And we've provided that in a format which is easy to consume for one of our other platforms. And when the Hazelwood coal power station was shut down in Victoria a couple of years back now, somebody took our data series and just used it, and, you know, we didn't know about it until it kind of happened and started blowing up on Twitter. And they created the Hazelwood waterfall, where they had all the time series, and as, you know, each of the generation units shut down, they had a website that people could go and see and kind of follow it live, right? Follow the Hazelwood waterfall as we shut down this polluting power station. And so that's just kind of one of the examples, and that's how I really like the digital twin ecosystem to work, right? Sure, we might have a platform, I have an interface here for you guys where you can go and explore and find this data, but then I really want people to take this data, individual data sets or in aggregate or whatever it is, and then develop their own applications on top of that, right? Now, they become part of the ecosystem, of the digital twin ecosystem, but they're not a digital twin, but they get use of this data. We get more productivity. Sure, you know, the Hazelwood waterfall wasn't productive, but it highlighted what was happening in the world, right? It informed users. And so that's really how I see things. It's the digital twin itself is not the end game for me, right? It's what people will do with that data and how they will use it. Absolutely.
So thanks very much, Rita, for the question. We're getting close to the end. We've got 9 minutes left, and I would like to just circle back to one of the points of this masterclass. We are leading up to the New South Wales Smart Places Summit, June 22nd. The idea of soaking in some of these different issues as we run through the series of 10 masterclasses is to surface important issues, try to identify things that either we make recommendations for, identify resources, help people get started on their journey, depending exactly which masterclass. In this case, we've just seen some really, really powerful examples of a whole range of different uses of the digital twin, and we've touched on some of the future, some of where we might go, a little bit tantalizingly. What do you think we need to know? What do you think we need to focus on for our summit, where we are raising awareness, identifying resources, helping people get started, make recommendations for moving forward? Tim, I'm going to very unfairly start with you.
Where do you start? I think, to be honest, although we're talking about tech and IM and data and all that other good stuff, I actually think the human element is the one that's overlooked far too often, and whether it's use cases or customer experience or whatever, I think that's the overlooked one. So the people's the central user, and the outcome isn't, as Matt's exactly pointed out, the point isn't the DT. The point is the outcome the DT provides. Same as the point's not the car, the point's the transportation the car provides. So it's a good synonym, I think, for that. And I think at the heart of it, it's then back to sort of training, awareness, capability, and sort of uplifting both private, public, and the consumer in line with where do we want to head, you know? And I think in many respects, that's probably the longest lead time and the longest effort and the hardest journey ahead of us.
You're muted, Ian.
Yes, I'm sorry, I was doing in 2020. So I was just saying how great that was, but you missed all of that praise. But yeah, focused on outcomes is really important. And in fact, outcomes are delivered for people. That's a really, really great point. Adam, I'm going to ask you next. What's the most important things that we need to come into the summit on the 22nd, knowing, understand, thinking about digital twin? And if you've got a recommendation, what might that look like?
Oh, look, there's so many different things that need to be considered. And look, I'd like to circle back to Digital Twin Victoria, which is, you know, no different than some of the work in New South Wales. And that's that there is significant lumpiness across government around skills and understanding. And that can be anything from, you know, understanding how machine learning works to, you know, even critically, how to put a business case together that uses digital twin technology. So to me, you know, that information sharing component is absolutely critical, and supporting the different communities and cities across states or different jurisdictions, you know. To some of the value that we've seen some of our ASCA members get in terms of, you know, digital twins and smart technology in rural areas actually far outweighs in terms of a percentage of their budget compared to metropolitan councils, you know, because they're driving across massive regions, and to put, you know, sensors on, you know, power generators and all these types of things, buildings and so forth is actually a brilliant use case for them. So to me, it's around the I suppose both the information sharing, but supporting that that business case development to ensure that there's ongoing investment in these places beyond the grants program.
That's great. That's fantastic. Matt, I'm going to ask you next. What's the most important issues for us to be aware of? What should we go into the summit on the 22nd being aware of? And if you have a recommendation.
I think the main thing for me is how easy it is to oversell digital twin right now. It is still very, very early for digital twins. I can show all this cool, snazzy visual stuff, and I can amaze people with, you know, what we're showing and all the data and all this kind of stuff. It is still very early. It's going to take years before we get these use cases locked down and we decide here is the use case that we're going to deliver on and why we're delivering on it, and figure out what the value of that use case is going to be. So I think we're still very early, and it's going to take a long time. We're not going to see the value out of digital twins in 2021, right? It might be, I don't know, 2025 before all that value, you know, we're raking in cash because of all the productivity we have and whatever it is, right? The GDP is through the roof because of digital twins. I think it's probably just something to be aware of, that I and others who demo in the digital twin space, it's very easy to make a snazzy demo.
Great, fantastic. And Marie, clearly you want me to give you the last word, and partly that's to say thank you for bringing Mats along to talk to the standards community as well as participating in our masterclasses today. But Marie, what do we need to know going into the summit?
I think I will start by just agreeing with everybody. So, but try not to repeat. So thank you, Adam, Tim, Mats. I totally agree with pretty much everything you say. The people part, I started with introducing that I think digital twins are an amazing opportunity to collaborate. So I think getting the people part right is really important. I think the biggest thing that I've learned is it's a really diverse group for digital twin that's going to make it work. We're from different data backgrounds, different sectors, and just continuing that good work on collaboration. The productivity one I think is really, really interesting, and I love the way that Tim presented that straight up. I've just recently surveyed 10 different people who are in digital twin across Data 61, and they're all in different groups. And I asked the question, is twinning necessary for the thing you do or the problem, that your research is solving? And the answer was actually no, pretty much from all of them. The problem can be solved, but we can do it so much better and more efficiently. We can save money and more productivity, et cetera, if we can twin. So I think that identifying the value and basing it on that productivity gain for the particular use cases that we know are the low-hanging fruit, and then being able to share that across, like Adam pointed to, it's a very lumpy, there's a lot of different levels of capability, I think will help us all uplift together. And I think that's part of the role that we're trying to play at Data 61. The other thing that I'm really, really keen on is it's really clear to us that there are data sets that are emerging that are really forming the foundation of urban scale digital twins. How do we accelerate the accessibility and the availability of those? And I think the only way we're going to do that is by really identifying the true return on investment in those data sets. So yeah, I think I've answered yes to everyone before me and just tried to amplify it as best I could.
Well done, Marie, and you brought us in on time. So, ladies and gentlemen, this is the end of this evening's masterclass, number 3 in the series of 10, leading up to the Smart Places Summit, June 22nd. Our next is will actually be on data, AI, and governance. And so some of the teasing out that we talked about this evening about the use of data and standards, and of course the issues around appropriate use of data, will actually be addressed in that masterclass session. I'd encourage you to join. This session has been recorded and we'll make the link available relatively soon. And so I'd like to ask you to join me in thanking Marie, Adam, Tim, and Mats for an excellent masterclass this evening. Thank you very much.
Thank you, everyone.
Thank you, everyone. It was a pleasure.
Yep.
Yes, the thing we miss, of course, is the actual sound of applause. Maybe we should get some recorded. I'm sure there would otherwise be thunderous applause for this masterclass.
All we hear is click and dong. Okay, see you guys.
Bye.
Thank you.
Thank you very much.